define sub, and I don't even need to make it very complicated. I just make it a very simple case. It does not even need to return. It will just do x gets x plus 1, return x, and define sub. Just by looking at the program the way it is right now, what is x? It has to be a global variable because it is not a local, it is not a biref, it is not a bival, and that leaves only one option. It has to be a global variable. Okay, so what we'll do is we'll say x gets initialized to say 5 initially. We'll say print invoke s3, print invoke s3. Just without even tracing the program, can someone tell me what it is going to print? What two numbers is it going to print? Are you sure? 6 and 7, because it adds 1 to x first, and then it returns the value of x. Okay, so it prints 6 and 7. So this is a very plain and simple illustration of how I can invoke the same subroutine, and each time I invoke it, it returns a different value. Okay, it also shows you the evilness of global variables. Why do you think a global variable x in this case is not such a good thing? If I just look at the invocation of S3, does the invocation itself tell me that it will change variable x, or that there's a potential that it will change variable x? Nope. The invocation itself tells me nothing about the subroutine going to change variable x. So, well, but Tech, if you're going to change variable x, you have to somehow give the subroutine the ability to change variable x. So how are we going to get around that problem? Well, let's take a look at another program. I'll save this one first because I might want to come back and trace this one if people want me to do that. Okay, so we'll call this evil global variable. Okay, because x is a global and it is bad, it is evil. So the next version I want to save is no global in subroutine. Okay, which is basically the same program. But this time, instead of using x as a global variable, what we'll do is we'll pass by reference something. So we'll pass by reference, well, I'll change the name of that to k, just so that we don't use the same letter. It is not necessary, but I just want to make it more clear. Okay. And we have to pass, that value over here. Okay, basically this program does exactly the same thing as the other program, right? Except we now have a parameter to S3, whereas before we did not have a parameter. But in terms of the effect of the statements, it will do exactly the same thing. It will print 6, it will print 7, and the value of the global variable x does change twice. The first time from 5 to 6, the second time from 6 to 7. Are you guys convinced that the program has the same effect on x? And it will print exactly the same thing. But I will call this a better program. It is a better program because if you look at the invocation itself, invoke S3 x specifies k, doesn't it tell you some potential that the subroutine S3 may change the variable x? It does, because of the double-sided arrow. It tells you that whatever we do in the subroutine to k will be done to x directly. In other words, just looking at the invocation, you already know, oh, okay, so x may be changed when I invoke the subroutine. As compared to the previous program, it is not spelled out. Okay, so that's why it is a bad idea to use global variables inside a subroutine. You should avoid the use of global variables in subroutines altogether. it is not because it can modify something that does not belong to the subroutine. Eventually, you have to do it somehow. But it is better to do it this way, using a by ref parameter, because the subroutine call itself, the invocation statement, states clearly that we may be changing variable x as a result of invoking subroutine S3. Okay, and that is a very positive thing, because now we can just look at the invocation and understand the potential of changing a particular variable that belongs to me. Is that okay? I mean, do you guys understand the point that I'm trying to make? Even though the two programs have exactly the same effect, one is considered better because it spells out the possibility of changing a variable. Is that okay? Okay. Now, with this class, we are already in the topics of types and records. Can someone remind me what was the last topic that we talked about in terms of types and records? No. Nobody remembers. It's 1 week ago. It's a little bit too far back. I can always watch my own video clip again. Okay. Come on. Okay, so let's go ahead and split the screen, because I can't really show all. I see what's happening. It's having problems. All local variables start with unknown values. Okay. We can also look at the files that we captured on the 23rd, if I had one. Uh-oh. Or did I upload that already? No, I didn't upload it.
Might be the 24th.
The 24th? No, that's a different class, I think. Is that what we talked about?
We talked about the reason.
No, these are all modified. This is the other class. I might have accidentally deleted the folder. Oh, that is not good. Okay. Well, let's go back here and just look at the notes. I think I might have deleted the folder. Okay. So let's see. I have to decide what to do, because let's go ahead and talk about coordinates, okay, which is an example of using. Have I talked about remote controls in this class? No? Okay, so that's a good starting point, because we have already talked about records. So now we need to talk about, how do you access a record? How do you access a variable that is a record of something? So what we'll do is we'll take a look at this. Let's see. Here is a new program, and what I'm doing here is to define a record type, which I will call a coordinate. Okay. A coordinate, at least at first, I'm going to use the XY coordinate, which means I need an X component to tell me exactly where on the X-axis the pixel is, and I need a Y to represent where on the Y-axis the pixel is at. And record, just like that. And this is going to be a very simple example. It doesn't really do much. Okay. Let's say we have the main subroutine here. And inside the main subroutine, I have a local variable that is a coordinate. I can just call my variable point, which is a coord, and I can, in order to initialize the point, I can simply access the x component of point and say I want to initialize that to, say, 50, and I want to initialize the y component to 0, and then I can do whatever I want with the variable point and define sub, invoke main, and that's my entire program. Do you see anything wrong with this program? Well, let's just go back and talk about what a record is. Have we talked about cookies and cookie cutters in this class? Okay. So in this case, what is a cookie cutter? Give me the name of the cookie cutter. Coord. Okay, the coordinate type, the record type is a cookie cutter. Give me the name of a piece of a cookie. Point. Okay, point is a cookie cut by the cookie cutter called coord. Okay, so you want to remember this analogy because at some point in an object-oriented programming class, you will encounter the same concepts again. A cookie cutter has many names in programming. It can be called a record type. It can be called a struct in C. It can also be called a class in an object-oriented programming language. Okay, so all of those terms refer to a cookie cutter. What is the job of a cookie cutter? To cut out cookies, right? Now, but what is so special about a cookie cutter and the cookies that they cut out?
They're all the same.
They all have the same shape. Okay? Now that is important because I can use the cookie cutter coord and create another local variable. Okay? And that other variable will have exactly the same shape as the first one. Even though the values will be different, they have the same shape. Now what I mean by shape in this case is simply to say that point as a cookie has a component called x. It also has a component called y, and both x and y are integers. Okay, are we doing okay so far with this? Okay, so let me save this program first, and then we'll go ahead and look at another program, and then come back and look at this one and say, well, which one is better? Why is it better? So we'll call this one no ADT. I'm not referring to the security company ADT, I'm referring to abstract data type. So this program does not use abstract data type. Let's go ahead and take a look at another program which is very similar to this one, except it looks kind of tedious and unnecessarily tedious. So we'll just take a look at the second program and say, why is the second program better? So we have the same thing. We have coord defined exactly the same excuse me, defined exactly the same way as the first one. We have an integer, component called x, and integer component called y. But this time I define an extra subroutine. The extra subroutine is called init coord xy. And what it does is it requires 3 parameters. The first one is a coord. Okay, so we'll just use lowercase as the name of the parameter and use coord to represent the type of the parameter. The other 2 are passed by value. One is simply x, which is an integer. One is y, which is also an integer. Is there a problem here? Can I use the name x and y again? Is there any chance of confusing the parameter x with the component x? Nope. There's no chance these two can be confused, and that's why you can use exactly the same name. The subroutine doesn't do anything really that useful. All it does is to say the x component of parameter c will get the value of parameter x. The y component of parameter c will get the value of parameter y. And define sub. That's all it's going to do. It's a whole bunch of stuff that doesn't seem to do